Hello, assalamu alaikum.
Walaikum Assalam wa rahmatullah.
As we start today the new chapter, I give the introduction before also. Let's start from again and now here. We will do what? We will find the approximation of the function at the given point x. And to find the approximation of the function, we have to use the rule. One of the best rules is called the interpolation. And we use the simplest interpolation form, which we call is the polynomial interpolation here. What we have to do here, we given the data point, we are given x0, x1, x2, and xn, and we are also given the corresponding function value of the function. So that's, we have the shape of the table with x value and the function value. And then our range of data point is from x0 to xn. So how we got table? Someone give us a table by experiment, by survey. We have no formula for that table. We only know the value of the function at x0, x1, x2, and x3, and xn. But we don't know the value of the function at the middle point here. So that's our job in chapter number 2. How can we find the value of the function at the point which must be inside the interval x0 to xn? And that procedure is called the interpolation. Is called the interpolation. That means if the desired x, if the desired x is between the largest and the smallest of the data point, smallest mean x0, largest mean the xn. If the desired, that means the x at which you are looking for the approximation of the function. If it is inside the interval, then we call the interpolation. And this is another range. There is another way to deal. If the x is outside the range, then we call it extrapolation. And extrapolation we will not discuss, inshallah. We discuss only the interpolation. So first condition, you have to be very careful, please. You have to check what data point is given to you, which you are using. And then you have to check which is given x here. And x must be inside the interval. If not, this is not interpolation, this is extrapolation. So that's the first point. You have to be very careful now. Then we go further in it here. As I say, if we go for the polynomial interpolation here, as I told you, we use polynomial interpolation to find the approximation of the function at the given point here. This is your polynomial equation of degree. And we have here now, that means this is a Pn. If the value of the function at the given table, Pn always equal to f of x. But if the value of the function x is not inside, inside the interval, then we will never say equal, we say approximate, please. That's the things we have to do, inshallah, in our chapter number 4. We have to find a polynomial Pn. That means we have to develop the formula according to the given table. This is a table I will show you. This is a table we are given here. This is always given in chapter number 4. And first our job is what? The first our job is, because we don't know what is the formula of fx. Someone give us like this one by experimental work or survey work, as I told you before. We need to find the approximation of the function at any point between x0 or x1 or x1 and x2 or so on. So we have to do what? First, we have to create the formula, which we call it Pnx, right? And this Pnx will do what? This Pnx will approximate the original function this we have. And now when you have the Pnx, you have the formula then of course you can find the approximation of the function at any point inside the interval. Then we have no confusion here. So this is the things we have here now. This is a formula we have here. The exact minus approximation should be less than epsilon. What is epsilon? Epsilon is a very small positive number. That means close to zero. That means the difference between the function, which is your alpha in this chapter, chapter number 4. What is your alpha? Alpha mean exact solution. Alpha mean the value of the function at the given point. This is your alpha, and that is your approximation. This is given by the teacher. This you have to calculate. Take the difference between them, and you can see you have a good approximation or not. So if you can see, if you have a polynomial degree n, how many points we need? Always remember that one, please. We need n plus data point here. That means if you have dealing with the degree n, if you have a polynomial degree n, you must have n plus 1 here. This is n plus 1 point here, starting from x0 and with the x0. This is the things here. Also, I forgot to tell you here, this data point x0, x1, x2, x3, this may be equally spaced or unequally spaced, right? What is the meaning of the unequally spaced and equally spaced here? That means if the difference between x0 and x1, x1 and x2, x2 and x3, and so on, if the difference between them is the same, then we say equally spaced data point. And if the difference between them is not same, then we call equally unequally spaced. We have many polynomial interpolation formula which work for the equally spaced, and we also have a many interpolation formula which work for the equally spaced. But inshallah, we will do 2 numerical method in this chapter, and both numerical methods say we don't care data point is equally spaced or unequally spaced. So no problem with that one here. Now, if you can see, if you have the degree n, you need n plus 1 point here. And for example, let's say if you have a polynomial degree 1, how many points you need for, please, any student? If you have a polynomial degree 1, how many points we need? If you have a degree n, you need n plus 1 point. If you have a degree 1, how many points you need?
2.
2 points we need, x0 and x1. And if you have polynomial degree 2, need how many?
3.
3 points. This is most important things you should remember here. Now, if you can see here, if you have a degree 1, you need 2 points. Now, of course, in exam or in our discussion example, inshallah, we will see we always have a many point. And we have to select only 2 points for the degree 1 and 3 points for the degree 2. How to select that point? This is the most important thing in chapter number 4. And that we can point here, only select. We have to check what is given x, because x must be given, because x is a such value where we are looking for the value of the function. So you should know what is x given. Then you have to choose such 2 points from the table which must be close each other, and this x must be inside, because if it is inside, then we call is the interpolation. If it is not inside the data, then we not call it. And the same thing happen here. If we say degree 2, we need 3 points. How to choose 3 points? Because your given table may be 5 points, 6 points. How you choose? The same rule. First, you should know what is your x. Then you have to choose just such 3 points which must be close each other. That means the distance between the size of the interval should be as small as possible. Smaller the size of the interval, better the approximation of the function at the given point. This is the point 2, 3 point and then you will see what lies the chapter number. This one is a very, very simple chapter. Number 1, you are given data, and in the data, you are given many points. So what is your first job? Your job is check which degree teacher asks you to use, degree 1, degree 2, degree 3. If we say degree 2, you have to do what? You have to select the point, 3 point, x0, x1, and x2. Before you select the 3 point, you must know what is the x at which you are looking for the interpolation. So when you look what is x, then according to that x, you have to choose such 3 points which must be close each other and x must be inside. If you have a degree 3 need 4 points, degree 4 need 5 points, continue like that. So that's the important things. That's the point information we need here. Now we are ready to use the formula to find the approximation of the function at the given point here. And for that one, we have to, as I told you, we have to use the 2 rule. The first one is called the Lagrange interpolation formula. This is one of the best polynomial, but also it has some problem. That problem I will tell you later on, inshallah. The Lagrange interpolating polynomial, and the other, inshallah, we will do the Newton polynomial. So these 2 numerical formula we do for the case of polynomial interpolation, which we are using to find out the approximation of the function at the given point we have here now. And the Lagrange polynomial, I give you the general formula for this one here. For the case of the first simplest formula is the Lagrange polynomial is the linear polynomial. And linear polynomial, how many points we should need? For the linear mean degree 1. And linear mean degree 1, as I told you, for degree 1 always we need only 2 points, x0 and corresponding function, x1 and corresponding function value. But in the table given more. And then we have to use, I prove the formula, but no need to prove the formula. This formula you have to remember. This is called the linear Lagrange interpolating polynomial, which is L0 x, f of x0, and plus L1x, f of x1. You are given what? You are given f of x0. You are given f of x1. The unknown coefficient Lagrange are L0 and L1. This is you have to calculate. And for this, you have to remember the formula. This is the things formula we have here now. To compute L0 and L1, L0, you have x minus x1, x0 and x1. That means you don't have x0 in the first, you have x0 in the denominator, and L1, you never have x1 in the up, should have in the denominator. This is easy to memorize here. When you calculate this value and that one, because these 2 coefficients are the unknown that you have to calculate, and when you calculate that one, put the value here, and that give you the jawab here. Of course, that jawab we will never write approximation. I write equal only because this is the formula, f of x always equal to p of x at the given point x0 and x1. But we are not finding the approximation at x0 and x1. We are finding between them any point. When you look for the approximation of the function at between point, then we write approximation here. After you calculate L0 and L1, one thing you have to be very careful when you find L0. You can easily check my L0 and L1 are correct or not. They must be equal to 1 for any case. If they are not equal to 1, it means something wrong with your calculation. Either you have wrong calculation or you have used the wrong formula. This is not you have to do in the exam. This is only to check that your calculated value L0 and L1 are correct or not here. Okay, then I give you the most important formula for the case of Lagrange polynomial, which is a quadratic Lagrange polynomial, and quadratic mean degree 2. Sometimes we say quadratic, sometimes we say degree the 2. And of course, as I told you, how many points we need for degree 2? We have to select the 3 point from the table x0, x1, and x2, and also the corresponding function value. And then we have to use, this is the formula for the case of degree 2 Lagrange polynomial. It means you are given f of x0, you are given f of x1, you are given f of x2. The only unknowns are this. You have to find out L0, L1, and L2. For degree 2, now you have a 2-term up and 2-term down for each case. And when you have L0, don't put x0 up, and in place of x, just put x0. And in the case of L0, L1, don't put x1 in the up, and then in the denominator put x1 in place of x. That's easy to memorize here. And if you go further, extended the formula, this is called the cubic Lagrange polynomial, and cubic Lagrange polynomial we call the degree 3, and degree 3, you remember, as I told you, we need the 4 points here. And this is the formula for degree 3 formula. And for degree 3, of course, we have to calculate the 4 coefficient, L0, L1, L2, and L3, because you are given f of x0, f of x1, f of x2, and f of 3. Only unknown are L0, L1, L2, and L3. That's you have to calculate here. The same thing, you should have now 3-term up and 3-term, and the same way, you have never have a x0 in the up, and then you denominator put in place of x0. The same thing like this. Then I give you the generalized formula, degree n, and the degree n is, this is the formula for degree. The n we have here now. And of course, you have to find out the value of L0, L1, L2, Li, and this is a formula we can have here now. This is, sorry, xn. This is xn here, not xi. This is xn we have here. No, it's okay. I'm looking for the approximation at xi, so this is okay. So this is the things you have here now. And of course, if you look for, you start with a polynomial degree 1. Degree 1, you have L0 and L1 is a very 2 coefficients you have, and only 1 term up and down. But if you increase the degree, your computation increase. Now you have 2 term up and 2 term down for each L0, L1, and L2. And when you go for degree 3, you have, so each time you can see the computation will increase. This is a problem of the Lagrange polynomial. Lagrange polynomial is not a good formula if you have a large data size point here. That, for example, if you need the degree 4 need how many points? 5 points. And degree 4 mean 5 points, and it means you have to calculate L0, L1, L2, L3, and L4, and each L should have a 4 term up and down. So it means it took time in the exam. We have to take more time in the exam here, which is not good. So from examination point of view, this is the best formula. And if in exam, any question come from the Lagrange polynomial, teacher must give you either degree 1 formula to use or degree 2, but 99.9% chance in exam is a quadratic Lagrange polynomial, and the quadratic Lagrange polynomial mean degree the 2 we have here. So this is our first numerical formula to find the approximation of the function at the given point. Though before I do any example, if any question come from a student, please can you just ask me if you have any question?
Everything is clear.
Is okay. Now you see we are almost in 20 minutes and we have only 21 students. So I just take your attendance because I want not to put the student who come late here. Well, this is the things here. They are very poor in the quiz and because they are careless. Please hurry up quickly. Please give me number 1. Number 2.
Yes, sir. Number 1, yes, sir.
Number 2. Number 3.
Yes.
Number 4.
Muhammad.
Number 5. Number 7. Number 8. Number 9. Number 10.
Yes, Doctor. Number 10, Firas.
11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23.
22 Abdullah here.
23. 24. 25. 26. 27. 28.
Yes, Ahmed. 27.
Okay, 28. 29. 30. 31. 32.
30 Doctor. Faisal.
32. 33.
33 Doctor.
Okay,
Muhammad Suwaid.
35.
34 Dr. Abdulaziz.
Okay, no problem. 35, 36, 37, 38,
37 Umar.
38,
Yes, 38.
39.
Yes, Khalid.
38 موجود or no?
Yes,
Okay. 39.
yes, 38 Muhammad.
Yes, okay. 39 is
39
okay.
Khalid, Doctor.
Yeah, 40,
Okay. Yes, Abdulaziz, 40.
41,
41 Abdullah.
42,
42 Ahmed.
43.
Yes, Usama.
Okay, I took the attendance. Please don't leave. You say the attendance is okay. Now we should leave here. Please don't leave.
Okay. Number 5.
Bismillah. Now let's continue now, please. We have the first example, and this is the application of the chapter number 2 here. In chapter number 2, if you remember what we did in chapter number 2, we find the approximation of the nonlinear equation, right? Nonlinear equation. Inside the interval, we have a root of the nonlinear equation approximation. So that's I say here. If you have f of x, now you see we have 20 students. One student already left. La ilaha illallah Muhammad Rasulullah. Let f of x is equal to cosine x square minus x plus 3.
And joined too many times. His connection to the internet, I guess.
Okay, sorry. Let f of x is equal to cosine x square minus x plus 3. And you say that, show that f of x has a root inside the interval. This is the first part. And then he say, use linear Lagrange interpolating polynomial to find its approximation. Then what we say let x is equal to alpha is a root. It's the same thing we do in the chapter number 2. And we say, this is a nonlinear equation given, right? And then we say, one of the root of this one is inside the interval. And you remember how we find the root is inside the interval? We have to take the value of the function at the end point of the interval must be opposite sign, negative and positive. The same thing we choose here. value of the function at 2.5, you know the function is this one is this. Value of the function at 3 is a negative, positive, negative. This happen here. So this is 100% guarantee. Root is inside the interval. So when root is inside the interval, we are ready to find its approximation. You remember in chapter number 2, we use many formula, bisection, Newton, secant, and fixed point. Here we will use how to find approximation of the function with the help of the linear Lagrange interpolating polynomial. This is a linear polynomial you have, please, which is a formula you can write here in that sense here. Now you can see here f of x naught. What is f of x naught given? 1.49 you have. And what is f of x1? F of 3 is a minus this one. So only things you have to calculate is what? You have to calculate L0 and L1 here. That you can calculate here. What is the value of L0? Is this one. And what is the L1? Is this one. Because we are not given x. What is x given? Is simple alpha. It means you have to calculate the value of alpha. Alpha, its approximation value. Then of course, what we have here now, this is a formula of the, and we know what is the value of the function in chapter number 2. Value of the function in chapter number 2 is always 0, which I mentioned here. This is a condition of the nonlinear equation. So we find this value, we put the value of what you can call it. We find the value of L0 and we put the value here because alpha minus 3, 2.5 minus 3 is a minus 0.5. And for this one, you have alpha minus 2.5, 3 minus 2 is 1.5 and alpha minus. So we have this one. Multiply with the f of x1 and f of x0. And we have this after putting the value in the formula. And then we put formula is f of x is equal to 0 because this is the always condition of the nonlinear equation. F of x must be equal to 0. And when it is 0, now you have to play with it, simplify and separate your alpha from this. And without alpha is on the right hand side. Calculate the value of alpha by taking this 4.82 in the denominator of that. And then you simplify. You have the approximation of the root of the nonlinear equation. This one with the help of linear Lagrange interpolating polynomial is 2.8. And this is correct value. Why? Because the root is majused inside the interval. So 2.5 is inside. So alhamdulillah, things are okay with that here. So it's mean the Lagrange polynomial we cannot use only for the approximation of the function, but also we can use to find the approximation of the now this, if you can say, teacher can give you one more part here. He say you find the alpha, right? Find the alpha. Alpha is what? 2.811. Then the second part, which is not given here, maybe in exam if I give here. In the exam, first part is this one, and second part I give you like this one here. First part is what? Find x. X mean alpha, right? Find x with the help of linear approximation. And what is the x you find out, please? 2.811, right? Now my second point is find approximation of, this is your job in chapter number 4. Find approximation of f of x at computed value of x. So what you do? Very simple. You already know what is your x. X is this one. So in place of this, you can say now f of 2.811. I'm right? Now you say this is approximate, not equal, please. This is approximate of what? P1, right? Approximation of P1. And then you do what? Same thing. In place of alpha, you just, in the first step, you find out is this, put the value of 2.811 and calculate this one, put the value of 2.88 here, calculate, and that will give you the jawab. Of course, should not be 0 now. It give you the jawab, and that jawab is what? The jawab will be the approximation of the function at the given x point. Because here, the question x is not given. Here your x is not given here. Because here he never said to find x here. He said find the x here in the first step. X is the approximation of the root of this, which is the root of this equation. So then when you have the root, then you can use it to find out the approximation of the function. This is a good example. Inshallah, I will add this part today, and then I will send you, when I will send you the complete with that. And this is also the second example we have here now. But I will not give you this one here, but you can check, please. I say f of x is equal to 0. We define on the 3 number minus alpha, and this one here. Okay. And then he say use Lagrange interpolating formula to construct the polynomial px, which interpolate f of x at the given number. Then show that the polynomial can be. This is the things here. He says show that the quadratic polynomial can be written in this form. So what is this one here? How many points you have? x0 is your -1, x1 is your 0, and x2 equal to h. So you have 3 points, and 3 points you have to use a quadratic polynomial, and that quadratic polynomial you will use here, inshallah, when you use. And you know the value of x0, x1, and x2. You don't know the value of x, so we don't care. And then when we simplify, you have this one. And now you can do what? Separate x squared term separate, x term separate, and without x mean constant term separate. And then inshallah you will get this value, and this is a jawab you will get. This is generally because the point is not very important here. This is a very good example from examination point of view. Many times I give in the exam here. Now, what is that one? He said, let P2 be a quadratic Lagrange polynomial for the data. You know how many quadratic Lagrange polynomial, how many points we need? We need the 3 points.
Right.
Yeah, so we are given 3 points. What is given x0? 1. What is f of x0? 2. What is x1? 2. What is f of x1? 3. What is x2? 3. And what is f of x2 is given alpha. Now he say find alpha if the constant term in P2 quadratic polynomial is 5. This is the first part. And the second one, find the approximation of f of 2. Now like this one. You remember what is the quadratic polynomial you have here? The quadratic polynomial is what? How can you write quadratic polynomial? We say P2x is equal to ax squared, right? You know this is a formula, a generalized formula you have in the school level. So quadratic equation, which we call is what? B of x plus the c. If you put this is equal to 0, then we call this is quadratic equation. If we put in the form of function, we call this is a quadratic function we have. This is a quadratic polynomial we have here now. Now, if you can see here, this is a quadratic polynomial. What is a for x squared? Any student? What is a called? How can you call what is a?
X coefficient.
Yes, and not x coefficient. X square coefficient. What is A? Is a coefficient of x square. What is B? B is a coefficient of x. And what is C? Simple constant, right? The same thing he say, let P2 equal to quadratic polynomial for the given data point. Find the value of the alpha if the constant term in P2 is a 5. So it's mean, well, you have to find the polynomial like this in this shape. This shape mean make your x square term coefficient, x square coefficient separate, x terms coefficient separate, and constant terms separate. And then what is given? The constant term mean C equal to what? The 5. And then you will find out the unknown, because unknown here is alpha. Agree? And when you know the value of alpha, and now he can give you the next question, find the approximation of the function at 2.5. Now you can see what is your data given? 1, 2, and 3. And what is your x given? 2.5. And this is interpolation because 2.5 is majud between 1, 2, and the 3 we have here. So what is your first job? Your first job always is what? You have to write the formula, P2 formula. And this is your P2 formula. Quadratic Lagrange interpolating polynomials you have here now. Now what you know, you can put the value. You know f of x naught. What is f of x naught given by the teacher? 2. You put 2 here. What is f of x1 is given? Is a 3. You put the 3 here. And what is f of x2? Alpha. You put the alpha here. It means the only things you have to calculate is what? You have to calculate L naught, L1, and L2. And this is the formula. You remember I give you L naught is this formula, and you simplify, inshallah. After simplify, you can multiply, and this, you can have this one. And same, you know, must know the formula of L1. You will get this one. And then you find L2. Now you have this one. So after computing the value of L0, L1, and L2, put in the formula. So you have what? L0 is what? This is the things, your L0 into f of x naught. F of x naught is a 2 already we have here now. And then you have to write L1x. What is L1x? Is a minus into f of x1, which is 3 here. And then you put L2, which is what? Is this one, into alpha here. Now what you have to do, open this, multiply and open this, and then separate x term, x square coefficient, x coefficient constant separate. When you do, inshallah, let's see, separating the coefficient of x square and the constant term, and then you have this shape of the problems. This is the coefficient of x squared, this is the coefficient of x, and this is a constant term without x here now. What is the question given here? Find the value of alpha if the constant term in P2x is a 5. So what is given here? Minus 3 plus 5. This is a constant term. And he gave what? This is equal to the 5. And when it is given equal to the 5, you have the value of alpha. And what is alpha? Alpha is A. You finish that part. After finding the alpha, he said, find the approximation of the function at 2.5. So you have to put here, the unknown things are what? Unknown things are alpha, and alpha you just calculated is 8. So you put 8 here, 8 here, 8 here. And then you calculate 2.5. Now, as I told you, now you have to put approximate, not equal, please. Teacher will cut your mark because the value of the function at the given point should be approximate, not equal. I put here equal because I didn't give you the x here up to down. When x is not given, you can write equal, no problem. So now in place of x, what you have to put? 2.5 here. And when you calculate, you will get, this is a jawab of the problem. This is very good example, please. Any student has any question, then I can explain, or I will continue.
Everything is clear. Alhamdulillah.
Any question? Is okay? Or any
Yes.
question, please?
Yes, everything is clear. Alhamdulillah.
Is okay, alhamdulillah. Let's go to the second example. He say he give you the value of function and he give you the data point. Up to now, example are very simple. It's not tricky one. A tricky one comes the later on. Let f of x is equal to this one, and you're given three. How many points given? And this is okay also. This is a good one. Let me check how can you behave this one. This is your function, and this is the given point. How many points we are given, please? 1, 2, 3, and the 4. Now he say find the quadratic Lagrange polynomial for the approximation of this one. How many points given? The 4. Here a student confused. Inshallah, you will also in the exam. You are given x naught is what? 1. X1 is what? 1.5. X2 is 2.5. And X3 is 3. This is given by the teacher. And we have 4 points. But you remember I told you, when we use quadratic polynomial, we need what? Only
3 points.
3 points. And 3 points are this one. Now student confused and they say x naught is 1 and this is this and this is this. No. This is the given by the teacher, but you have to select by yourself your new, maybe the new x naught, new x1 here, depend on your what? The x. What is your x given by the teacher?
2.7.
Now you have to look such 3 points which is close each other and 2.7 is majood inside here. Now for this example, a student directly use, they say we need x0, x1 and x2 and they use, this is a given from the teacher, this value use x0 is equal to 1. This is 1.5 and this is 2.5. These points are correct or not?
Not correct.
Not correct, because what we are doing the interpolation, and interpolation condition is this x must be inside the interval. Interval mean between smallest and the largest value. But 2.7 is not inside, though this is wrong. It means what you have to calculate, you can
X3.
Can you take this one now? Interpolation is okay or not?
Yes, it's okay now.
Yes, it is okay now, but you have the big distance. How many distance is here now between that? 1 and 3 is a 2, right? As I told you, the size of the data point should be small. Smaller the distance, better the approximation. In exam, teacher always say find the best approximation. It means you have to choose the best point. It means your x0 should be what, please? 1.5. This should be what?
2.5.
And this is, what is the distance now? Is a 1.5. Small is the size of the interval because you have to select such 3 points which must be close each other, and the main condition that x must be inside. If you use the points and your x is not majood inside, teacher directly give you 0 marks. He will, because this is not interpolation. But if you choose wrong interval like this one, you choose 1 and 3. Yes, it's not a nice interval, but interpolation exists. He can give you some marks here, not the complete marks here. Therefore, you have to be very careful in choosing the points here. The procedure to choose a point, that it should be close each other and x must be inside here. Now the things, now we are ready now. All the information we have here now. So we need the formula, this one, and we need the x is this one. So it's mean we have to select the best three possible point, because we are given 4 point, we have to select only 3, and the best 3 point which are close each other, and that's the things you have to. Your x naught and the teacher x naught, 99% chance not equal, but still 1% chance may be equal, but generally not equal. So because teacher confuse you here, that the student will choose the same here. So this is your x naught. You compute by yourself, and then you find the value of f of x naught, and then you find the value of the f of x naught, then you find the value of fx2, and after having this one, put the formula. This is the formula you have. F of x naught is this one, f of x1 is this one, and f of x2 is this one. Only you have to calculate the value of L2 here. So now you can have here, now you have, this is fx. I just find the polynomial. No need to find the polynomial here, because already given the x is given by yourself. No need to do separate here. Just put x here is what? 2.7, and then you have some number. Put here to calculate this one. Or you put here in x is equal to 7. It's the same thing here, please. And when you put x is equal to 2.7 here, here, and here, and then you can check this plus this plus this should be equal to 1. If it is not 1, you make some mistake somewhere, recheck again here. But if you make the polynomial, and then you can separate like this one here, and then he say find the 2.7. So in this way, because this I put here, last time I asked in the question is a 2-part. I say find the quadratic Lagrange polynomial, the first part. And this is a quadratic polynomial we find out. Then I say use it to approximate f of 2.7. And then after you have this polynomial in place of x, you put 2.7, and then you can have, this is the approximation you have here. This is the job we have. And also he say find the relative error. Relative error is what? Relative error is always absolute error taqseem by exact solution. What is the exact solution? F of 2.7. And what is f of 2.7? How you calculate? Because teacher give you this one. You can easily find out f of 2.7 when you put x is equal to 2.7 here, and that will be your alpha. This is your alpha. This is the value of the function at the given point is always your alpha exact. And when you do this one here, and this is your exact value, when you calculate approximation, you just find out by yourself, taqseem by the exact solution. If he say find the absolute error, no need for this one, only the upper part. But he say find the relative error, you have to, absolute error must be divided by the exact. This is the formula of the relative error. And you have a very good error here. Is a 10 minus 4 accuracy, 8 multiply 10 minus power, 10 power minus 4 here. And this is I calculate here, please. If you put x equal to 2.7 here, so L naught will be what? When you calculate, inshallah, you will get this one. This is no need to do in the exam here, please. This is only for your checking that my calculated value are okay or not. And when you put x is equal to 2.7 here, inshallah, you will get this one. And when you put x is equal to 2.7 in this case also, and you will get 0.3. And when you have this one, as I told you, always for any problem always should equal to 1, and you got here is the 1. So alhamdulillah, over calculated, because this is the only things we have to calculate. Rest is a given. So that is the important things to do here. We have to compute, and alhamdulillah, this is equal to 1. So this value is good. No need to do this one in the exam, please. This is only for your checking here that my calculated value L0, L1, and L2 are okay or not here. We do a lot of example for this case next time, inshallah. This is also a very good example. Next time we will do here. Have any question now, please?